we'll move on to our next speaker, who is Christian Gscheidle.
So hello everyone, I'm Christian Gscheidle, a graduate student at the Technical University of Munich in Germany, and I'm glad to quickly present to you work on the KNUDSEN diffusion coefficient of order through NULHT2M regolith stimulant. My colleague Laura and I performed at TUM in support of ESA's prospect study. Basically, we measured how the gas diffuses through regolith by measuring the transient response of a small gas pulse's flow through a sample. We used a high-speed pulse valve and a mass spectrometer under high vacuum, which is known as a fast pulse technique. To the measurements, we then fitted an analytic solution of fixed second law and got the pore diffusion coefficients, which we then post-processed, gaining the desired diffusion coefficients of order through the sample. We varied the sample compactions and the sample temperatures to get a more broad view of the measurements. We found that for decreasing sample compactions and for increase in the temperature, the effective KNUDSEN diffusion coefficient also increases, and it to be in the order of 6 times 10 to the negative 6 meters per second squared. Our results are in good agreement with theory and literature, and they provide a basis for modeling volatile migration through regolith, for example, to investigate the volatile loss during sample transfer, in our case for the prospect study. So thank you for your interest, and especially for the great conference organization. We are happy to answer any questions you might have later. Our poster is number 12 at today's polar exploration poster session. Thank you.
Great. Thank you, Christian.